So we're going to graph f of x equals negative x squared plus 2x plus 3. Our first step is to find the vertex, or sorry, the axis of symmetry. Axis of symmetry, which we can find by x equals negative b over 2a. In this case, a is negative 1, b is 2, and c is 3. So when we plug those in, we get x equals negative 2 over 2 times negative 1. So x is negative 2 over negative 2, so x equals 1, and that is our axis of symmetry. Yay. So our next step is to find the vertex. And we can always get that by plugging in what we just got for our axis of symmetry into our original equation. So our original equation was f of x equals negative x squared plus 2x plus 3. I'm just going to plug in the 1, so y, because f of x is the same thing as y, will be negative 1 squared plus 2 times 1 plus 3. So y will equal negative 1 plus 2 plus 3, so y is 4. So putting the axis of symmetry and this y value together, we have that the vertex is at 1, 4. Joy. So next step, we need to find intercepts. So we'll find our x-intercept first. And you can always find x-intercepts by letting the y equal 0. So remember our original equation was y equals negative x squared plus 2x plus 3. So if I let y be 0, I'll have 0 equals negative x squared plus 2x plus 3. And I'll just solve this. I'll try to factor. So if I divide everybody by a negative 1 first, to get rid of this negative sign here, I'll get 0 equals x squared minus 2x minus 3, and I can factor this to x minus 3x plus 1, so x minus 3 equals 0, or x plus 1 equals 0, so x is 3, or x is minus 1. I got that by adding the 3's and subtracting the 1. So those are my x-intercepts. So 3, 0, negative 1, 0. So when x is 3, y is 0, and when x is negative 1, y is 0. Those are my x-intercepts. And then to my y-intercepts, you can find y-intercepts always when x equals 0. So remember the original equation, always going back to that, is y is negative x squared plus 2x plus 3. So if I let x be 0, I'll have negative 0 squared plus 2 times 0 plus 3. So y is 0 plus 0 plus 3, so just 3. So my y-intercept, when x is 0, y is 3. Alright, so now I have everything I need to graph. So if I graph all these, alright. So step 5 is to graph. And we're just going to graph all the pieces. Remember in step 1, we got that the axis of symmetry was x equals 1. In step 2, we got the vertex was 1, 4. In step 3, we got x-intercepts of 3, 0, and negative 1, 0. And in step 4, we got y-intercepts of 0 and 3. So if I just graph all those, let's see, so the axis of symmetry is x equals 1, so that's this vertical line there. The vertex is at 1, 4, so 1, 1, 2, 3, 4. That's my vertex. X-intercept of 3, 0, and negative 1, 0, and a y-intercept of 0, 3. So those are the points I have. I know it's symmetric over this axis of symmetry, so if I have this point here, I can get this point on the other side for free. So if he's one away, then he's one away. Got an extra point for free. And that's plenty of points to be able to sketch my parabola. If I needed more points, if you couldn't quite see where the parabola was going, you could graph more. So I'll say plot extra points if needed. So this case would be fine, but you can always go to an XY table and try to figure out some more points. So let's say I wanted to know when x was 4. Remember my original equation all the way back to the beginning was y equals negative x squared plus 2x plus 3. So I'll have y equals negative 4 squared plus 2 times 4 plus 3. So y is negative 16 plus 8 plus 3. So y is, let's see, it's negative 8 plus 3 is negative 5. So I'll have the point 4, negative 5. 1, 2, 3, 4. 1, 2, 3, 4, 5 down there. And that's just another point that I could put on my graph. So, pretty parabola, and that is it.